All right, so forms of linear equations. First thing I want to show you is the slope-intercept form. So take any point, let's say that point there, and that's going to be 0, b. And then let's say we have another point somewhere random, x, y, and we make a line through those points. So all of those points are on a line described by these 2 points. So can anyone find the slope of that? So can I put for rise y minus b? Yes? Okay, similarly, how do I find my run? My x, and this is my 0. If this was a 3 and this is a 0, what's this distance? 3 minus 0, right? But in this case, it's x minus 0 because I'm saying what if it is in general, some random line that we don't actually know the points for. Okay, so now if you take this, you have m equals y minus b over x. Take a minute and solve that for y. Okay, so we multiply both sides by x, and we get mx equals y minus b, and then we add b to both sides, and we get y equals mx plus b. Okay, so if we have y equals mx plus b, what part is the slope? M is the slope. And what does B mean? The y-intercept. Because that's what we called it, remember, right here? That was the y-intercept because that was the point at which the line crossed the y-axis, right? So B is the y-intercept. Slope-intercept form is the form where you have y by itself, and then the m and the b are supposed to be numbers of some kind. But if you have y by itself, then the m is always going to be your slope. So you could find 2 points and find the slope using the y2 minus y1 and x2 minus x1 if you want. But if you can get it into that form and it's really nice, then whatever is by that x, you can just treat that as your slope here. So if they ask you to write an equation of a line with this slope and this y-intercept, and y-intercept implies that it's 0, 4 is the point. So write the equation of the line and graph it. All right, so this is your m. So we know this part for sure, but we aren't really sure about this part necessarily. I mean, in this case, it's really easy because they already told us the y-intercept, and b is always the y-intercept point. So you can literally just plug in 4 right now because you know that that's the y-intercept. But sometimes this point won't be a y-intercept. This point could be something else. And then you can plug in the x and y and then solve for b. But in this case, you're done like that. We'll look at a couple other examples where this point is different coming up. You could start at the y-intercept because you know that that's a point for sure. So where would that be? Well, that's, see, if I put in a 0 here, right, then I'll have negative 2/3 times 0 plus 4. What's that going to equal? 0 plus 4 is 4, right? So our y point is 0, 4 is our point there, right? So we know for sure that that's part of our line, but the rest of it we can find by traveling with the slope. So how do we travel with negative 2/3? So that's a rise and run. I'm going to look at it as either negative 2/3, or you could look at it as 2 over negative 3. But can we look at it as negative 2 over negative 3? Because that would be a positive, right? 2 negatives would make a positive. Okay, so if we read this one here, what's that going to do for me? What's the rise? Down 2. What's the run? So I'd have to go down 2 and 3 right. Down 2 and 3 right. This, can someone translate this for me as down and up and right and left? The 2 over -3, someone else? Give it a shot. Up 2, left 3. You could rise 2 and left 3. The negative has to go somewhere. Does that make sense? Okay. So then see, that's all on one line. Nice straight line. You guys should use a ruler. I'm not being a very good example there, but there's our line. So all of these points along this line, any point you find, you should be able to plug it into your equation, this equation, and it should work. The other one was slope-intercept form. So slope-intercept form is y equals mx plus b, because it's got the slope and the intercept together. Does that make sense? Okay. A slope and a point. So we'd have an m and like an x1, y1. Right, so that's what we could be given. So let's take any random point. Now, I'm going to make them completely random so you can't really tell here. Let's say that that here is x1, y1, and then this here is some xy. And between them, there's a slope m. So can we take that slope formula again, and can you tell me what the rise would be between those points? Sorry, I'm going to make this the point and this the random one. It's just going to make life easier. So what would the rise be between those points? X minus x1. So x's are down here, so then that would be the run, actually, right? So the run would be x minus x1, and what would the rise be? Okay. So if we took this and multiplied both sides by x minus x1 to get rid of the denominator, essentially have y minus y1 on this side and m times x minus x1 on this side. There is no y-intercept this time. So the other one depended on the fact that we have a y-intercept given. And remember when we're like, what if the y-intercept's not given? This is another example. This is more general. So this helps you when the y-intercept's not given. Just a point, a random point is given. So the slope point form is actually this equation. And you can see that it literally comes from the definition of slope. So as this says here, it says this is easily most useful when writing the equation of a line, giving a slope and a point or 2 points. So let's try a couple examples. So let's say the first one, and you guys are going to do this first. So write an equation of a line with this slope. So that's your m. And it passes through this point, so that's your x1, y1. And this was what we had as a result of our point slope equation. So you'd have y minus 3, and then negative a half x minus negative 4. So be careful to include your negatives in your brackets as well. So that's actually an x plus 4. And now if you distribute that, negative a half x, and then negative a half times positive 4 would be negative 2, right? Half times 4 is 2. That's where that came from. I just put it there just to remind you to always remember to put your variables in brackets when you replace them because of the double negative potential being there. I find if I put the bracket there, it helps me to remember to put that negative in there, not to forget it. So then you'd add 3 to both sides, and you have it in y equals negative 1/2 x. Minus 2 plus 3 gives you 2. So did everyone else get this? I think you were halfway, yeah? Okay. Awesome. You'll get the whole way on the next one. Okay, so can we graph this? Let's practice graphing because very soon in the next lesson you're going to be needing to be really fluent with graphing a line equation. So if you have a line equation, you could find points, but you could also use the slope to your advantage. So if you know your slope, who can translate this slope for me? Negative 1/2 is the same as, how could you translate that with down, up, right, left? Down 1, 2 over? So down 1, 2, right. So down and right. But we need to start somewhere, right? You can't just do a slope without knowing where you're starting. So what's a starting point here? You could use the y-intercept, which is what? So you could start here because of the way you solved your equation, or you could also start there as well, because that's also a point you know that's on your line equation. You can start in any place that you know for sure is there. So if you start here, you go down 1, right 2, down 1, right 2, or up 1, left 2, and you have your beautiful. Okay, let me try this out. So what did you guys get for your slope? You got negative 1/2 minus 1/3 over 5 minus 5/6. Some of you multiplied everything by 6. You guys had negative 1/5. There's an error here. Where is it? Oh, 35. Oh, yeah. 35 minus 5 is positive 25. Good. So that's negative 1/5 is the slope. And so essentially what you guys needed to do is take that slope, pick one of these points. It's probably easier to pick the point with less fractions. So I would pick this as my x1 and y1. So I'd go y minus negative 1/2 equals 1/5 times x minus 5. And that way when I go through it and distribute that, this is y plus 1/2 equals negative 1/5 x plus, what's 1/5 times 5? Positive 1. And then I just have to subtract the half from both sides, which leaves me with y equals negative 1/5 x plus a half. I think I saw that in a couple places. You guys got it? Okay, last bit. You could have also standard form. And if they ask you about standard form, it looks like this. So essentially, with the x and y terms on the left and a number on the right. So it's very useful when you try to use x and y intercepts to graph. So this is kind of, I want to go over this because in 084 you did the first two. In 085 we're also kind of learning more about this type as well. So let's just talk about if we have this format, how would we find the x-intercept? What is an x-intercept anyway? If you have a line, where's that point going to be? Describe to me what the x-intercept is. Crosses the x-axis right there. So what does the coordinate look like? Which component is 0? Anybody? Like if you were going to plot a point there, which part would be 0? The y part, right? Because there's no height. There's just left and right. So the y part is 0, and this part is x, right? Let's plug that in and see what we get for our x-intercept. So if we had ax plus b times y, which is our 0, equals c, well, this whole thing is gone because it's a 0 times something, so it's just a 0. So you've got ax equals c. So in this case, what's our x-intercept? C over a. So similarly, I want you to find what the y-intercept would be in general based on that format. So do the same thing. What would the y-intercept have? Which component would be 0 for the y-intercept? The x, right? Because there's no side to side, just up and down. You're going to do the x being 0. So finish that off on your page. Get it? Okay, C over B. That looks right. I mean, you can always find this. You don't have to memorize it, but I'm showing you this is how you would find an x-intercept, is plug in the 0 for y. This is how you'd find the y-intercept, plug in a 0 for x. How would you find the slope? Any ideas for finding the slope? So if you can take this formula and solve it for y and tell me what the slope part. So it's very useful to use a x and y intercepts to graph an equation. So let's say you had something in standard form. Can you find the x-intercept for me? Okay, we're almost done here. So the x-intercept, you're going to let the y be 0. And so when you solve that, you get 4, but do we answer it like that? No. We answer it as a point, 4, 0. So that's 1 point, 4, 0 right there. What do we do for the y-intercept? Let the x be 0 and solve for y. So you have negative 4y equals 12. Divide by negative 4 is negative 3, so you get 0, negative 3. Okay, so say you had this line here, what would that be? That's vertical. What are all the x points there? X is 2, right. X has to be 2. Or that could have been anywhere else, so let's just say x is a, some a. Doesn't matter, it could be at negative 3, negative 5, wherever it's placed. So what about the horizontal line? What pattern are you going to see there? The y is always 2, but the x changes, right? So the y, they usually say y equals b, because b is usually title for y-intercept. It's just a standard letter for that. Okay. So if you have an undefined slope and the point is 2, 3, what would the line equation be? With that, it's undefined, so is it horizontal or vertical? Vertical. So what does that mean? Is the y going to be the same or the x going to be the same? The x is placed somewhere along the x-axis, right? It's always the opposite of what you think, right? Because you think up and down is y, but it's actually the x that's held together. So what would we have? X equals? And what do we know? 2 in this case, because it's got to go through 2, 3. So it's got to be there. Horizontal line through negative 2, 5. 5. What about it? Stays at 5. The y stays at 5. So those are just some ambiguous examples. Sometimes you don't use any of those forms that we talked about, those 3 forms we talked about. You don't need them if you have a horizontal or vertical. You just go with that knowledge.